When you are configuring IP address for a set of devices, there are several issues that can arise as more devices are added to the same IP network. For example, if all the devices are in the same broadcast domain, so broadcast traffic will grow dramatically as more devices are added to the network. As a result, traditional broadcast traffic will consume host resources as the host now has to filter that additional broadcast traffic while searching for traffic that is specific to the host. The concept of subnetting is used to address these and other concerns relating to having a large flat network by logical dividing that network into smaller networks. And there are many advantages of subnetting a network. For example, smaller networks are much easier to manage and easier to map to geographically or functional requirement. Smaller networks contains the broadcast traffic to the individual subnet, which reduces the overall amount of broadcast traffic, thereby improving performance. And of course, it is easier to apply network security measure at the interconnection between subnet than within a large single network. In a network with multiple smaller subnets, connectivity between those subnets is provided by using a router. And the IP addressing that is using in a large single network need to be modified to accommodate the requirement of segmentation. By introducing a subnet mask, we can identify the network significant portion of an IP address. Now the network significant portion of an IP address is called the network address, and it simplify identify the network that the host device is on, and it also define every subnetwork. When you express an IP network address, you add a prefix length to the network address, which is the number of bits in the address that give the network portion. The entity that is used to specify the network portion of the IP version 4 address to the network device is called the subnet mask. The subnet mask is used by end system to identify the destination IP addresses as either local or remote. Router use a subnet mask to help determine the path to the network. A subnet mask defines the number of bits that represent the network and the subnet part of the address, just like the IP version address. The subnet mask is made up of 32 bits, and it uses ones and zero to indicate the bits of the address that are the network bits and those that are the host bits. You express the subnet mask in the same data, data decimal format as the IP version 4 addresses, and it is configured on a host with the IP version 4 address to define the network portion of the address. And network are not always assigned the same prefix. Depending on the number of hosts on the network, the assigned prefix may be different. Having a different prefix number change the host range and the broadcast address for each network. Variable length subnetting, subnet masking, or VLSM refer to the concept that subnet can be created with a different subnet mask length. One of the benefits of VLSM is that the IP address can be more efficiently allocated to each subnet. For example, a point-to-point connection only needs two IP addresses, one for each of the two devices. Therefore, creating a /30 subnet which creates subnet with only two hosts, making a lot of more sense than using a 24 subnet where 252 of the 254 available IP addresses will never be used. VLSM allow for more hierarchical level with an address plane. This enables you to take a major network such as Class A, Class B or Class C network and divide that network into subnetworks. In other words, VLSM allow more than one subnet mask within the major network and allow you to subnet previously subnetted addresses. So this was all about from IP subnetting. Thank you so much.